Hello everyone, welcome to the live class. So buffering, okay. Is it okay now? Please let me know, because I think it should be fine at this point of time. Yeah, it's showing like it will be all right now. Done? Clear? Please mention it in the comments now if you are able to see the video properly and even the audio is fine. So you can mention it in the comments. Earlier I know, okay, that's good, that's good, that's good. Which means we can continue the discussion and we can talk about all these important points. We can start the discussion now. Clear? Thank you so much, Priya. Yes, Vidhi, now it will be fine. If it was not okay earlier, please either refresh the page once, refresh the video once. It will be all right then. Clear? And if there was something not going on well, it should be okay now. Clear? Okay. So guys, as you all know, today's session is about the quantum mechanics most important concepts and questions. But before starting the discussion about these important questions and concepts, I am gonna tell you about some of the important points, like the information regarding some of the important points I will provide you here in this session today. So basically guys, as most of you will be familiar with this thing that we are going to have a new batch course which has recently started on Unacademy Plus, and this is the Aspire batch, and this is gonna be a detailed course, okay, by the different top educators. So you can see the details about it on the screen right now. Since it has recently started on Unacademy Plus, so even if you were waiting for the detailed batch or detailed course for your upcoming exam preparation, then you can even start attending the sessions of this batch course. Along with this one, even there are many other batch courses which are going on Unacademy Plus and will start in upcoming days in Unacademy Plus. So if you want to join these detailed batches, you were waiting for the detailed courses, now guys, you will start getting the detailed courses on Unacademy Plus, and you can take the Unacademy Plus subscription. And along with that guys, by using and by applying the referral code which is Anjali Arora as mentioned here on the screen, you will get the 10% discount in the total Unacademy Plus subscription amount as well. So this is something like which will even provide you the 10% discount in the total Unacademy Plus subscription amount. Let me just make it clear. One second. Is it all right now? It's clearly visible now. Done. And also guys, along with that, there is one more referral code which is Anjali A Live. You can use either this referral code or you can use the referral code which is Anjali Arora. Any one of the referral codes you will use. At a time you can only use one and apply it. At the same time you will get the 10% discount in the total Unacademy Plus subscription amount. Along with that guys, we are going to have the iconic subscription as well on Unacademy Plus along with the Plus subscription. So if you want to take the iconic subscription, what are the benefits you will get in the Unacademy iconic subscription? That has been shown here on the screen. Okay, even if, just by knowing about it, you can just try to decide this thing that which one you want to take, the Plus subscription or the iconic subscription. Both will help you in your exam preparation. Okay, and once you will take the Unacademy Plus subscription to attend the important live sessions of the well-structured and well-planned courses by the top educators, guys, when you will start your preparation in this way, you will be able to get the guidance by the top educators. You will be able to attend the live classes of well-structured and well-planned courses, and these are the courses which have been planned in such a way that in each and every course we are going to have the doubt clearing sessions, okay, after some number of sessions. And even let's say if any course is already going on right now and you think you want to continue in that particular course sessions, you want to attend the sessions of that course, so in that case guys, whatever sessions have already been conducted, you will be able to check out the recordings of those classes, as the recordings of the previous classes will be available to you, and that's how you will not miss anything. You will be able to cover up each and everything easily in this way without missing anything. Clear? Or even in upcoming days, anytime if you will not be able to attend the live session, so recordings will be and cover up that part by watching the recordings of the classes, the discussion which has been done there, and that's how everything will be clear to you. Clear? Now let's start the discussion about the quantum mechanics concepts and questions. Okay, and guys, at any point if you will have any doubt, you will tell me about it. Done? That's very good, guys. Clear? So I hope you all are even ready for the discussion about the questions which we will consider and we are going to discuss in this session today. Our first question, I'm just going to give you the first question now. Okay, at any point if you will have any doubt, you just need to mention it in the comments and I will talk about it. So this is from one of the very important concepts of quantum mechanics. And what is the question? Let's talk about it. See, just a second guys, I have to make a little bit change. We are going to have x and p. Okay, what is the x here? That is position operator. Clear? And you are going to have p as the momentum operator. So x represents the position operator and p represents the momentum operator. Clear? These are the two operators and their notations have been given to us. Clear? Now in this case you have to just consider one more condition, that is commutator bracket of x with p, that has been given as what? It's gonna be iota, because h cut they have taken 1 just for the simplification part. Clear? Next point, they have given you the question that's gonna be what is the commutator bracket of x with p e to the power minus p. This is what you need to find, the commutator bracket of x with p e to the power minus p. There can be different approach, okay, you can take to solve this question, but which one is the better one and which one will give you the answer quickly and in less time? We'll talk about all these things too, because in the exam it is very important to manage the time and to know how you can solve more number of questions in the limited time. So we will even consider that point. And once you will get it done, whatever option will be correct according to you guys, you can mention it in the comments. Okay, now please let me know once you will get it done. And if there will be any doubt you will have anywhere, something is not clear to you, okay, then in that case you can tell me about it and we will discuss those points. Please let me know which option is correct according to you, and if you are not getting it, I will discuss. I'm going to tell you about all these important steps which you have to take to solve it. Mention your answer in the comments, guys. Very good, Ashi. That's good. Option A. Okay. Let's wait for others' reply too. Okay, what is the right answer according to other students? And after some time, I will start the discussion if required. What about others, guys? Whatever option will be correct according to you, you can mention it in the comments, that whether it is option A, B or C or D. So one answer is there in the comments till now. It's okay, Rahul, I will explain it then. Guys, if anybody else is going to get the final answer, the final option, then you can mention it in the comments and let me know which option is correct according to you. And one more information, guys, that is about the special classes. So as you are familiar, we are having the target All India rank 1 to 100 special class series going on. Special class means the free live sessions, okay, and I'm conducting the sessions in that series on Thursday and Saturday in this month. Clear? So tomorrow at 12:30 we will have that session. Along with that, today after this session at 1:30, today exactly, okay, at 1:30 we will have a special class which is about the how you should attempt the questions in the exam. What should be your strategy when you are just gonna plan which section question, which part question you will attempt first. Okay, so that strategy session we will have at 1:30, which is a special class, which means a free live session. And if you want to join it, in the description box of this video there will be the link for the free live sessions. From there you can get the link for that session too, and you can join it at 1:30 after this one. Very good, Manisha. Very good, Priya. Okay guys, now let's talk about it. See, this is the question based on the commutator bracket, okay, and they have even given you the commutator bracket of x with p as iota, its value they have given, and they have given you h cut. They are taking 1 for just the simplification and for making the calculation part or other things simple for this question. So what we have to do, and those who are getting option A, that's the right answer. See, you have to find the commutator bracket of x with p e to the power minus p. There are different properties of commutator bracket. Either you can do one thing, you can write the series expansion of e to the power minus p here, and you can start solving it with the help of commutator bracket. But there is a relation between the commutator bracket as well as the Poisson bracket. For example, the commutator bracket of A with B, because commutator bracket is something we consider in quantum mechanics, which means we will have operators there. So commutator bracket of A with B will be equal to what? Iota h cut, the Poisson bracket of A with B. Okay, this is the relation between commutator and the Poisson bracket. But the point is, here if we are gonna write it just by taking the series expansion of e to the power minus p, we will keep it commutator bracket, and then we are gonna simplify it further. It will be very much time taking. So that is one approach. If you want, you can follow that. And even to make the thing simple for you, they have even given you one condition. But at the same time, if I will write it in terms of Poisson bracket, how I will get it? It's gonna be iota h cut. So since h cut is 1, I don't need to write it. Okay. And Poisson bracket of what? X with p e to the power minus p. And what is the Poisson bracket? It is one of the concepts of classical, but there is the relation between commutator and the Poisson bracket. So the point is, because it can make the things easy for us, we can consider this one instead of taking the commutator. So that's a good approach, you can say, a less time taking approach here. So what is the expansion you will have for the Poisson bracket? You have to take the partial differentiation of first term with respect to the position coordinate. And what is that? That's gonna be x. So when you will differentiate it with respect to x, what you will get? 1. Okay. Plus you have to consider the into the partial differentiation of the second term, okay, with respect to p. So when you will do that, first term, second term, you have to use the product rule. First term as it is, partial differentiation of second term will give you what? Minus 1 here along with e to the power minus p. Plus, okay, done, plus sign because you are using the product rule. And here you will have after this, that's gonna be second term as it is, which is e to the power minus p, and first term differentiation, that will be what? Just 1. For p it will be 1 because you are differentiating with respect to what? With respect to p itself. Next point, if you will check out the second bracket of the Poisson bracket, you have to differentiate this one with respect to p for that, and it will give you 0. So the point is, you don't need to write any other term except this one. What you will get finally, you can take the e to the power minus p common from here. So what you will get? Iota 1 minus p and e to the power minus p. And where you are going to have this expression, it's going to be in option A. So this is the right answer for the question given to you. Now Poisson bracket was the simple approach, less time taking approach, and that's how in very less time you can get the answer for this question. I hope it is clear to you, and if there is any doubt, please mention it in the comments. Okay. Yes, Rahul, just a second. Look at this. Now I hope it's clear. Done? Or done? Please let me know if there is any doubt anybody will have. Vidhi, I hope it will be clear now to you as well. Okay, Ruchika, I will just check it out later on. Okay, for the next part or next question, we will not write it there. But let me know, guys, if there is any doubt still you are having. Done? Is it clear? Clear to everyone? And if not clear, guys, you can mention that point wherever you are having any doubt. Okay? Can I give you the next question then? Ruchika, Vidhi, Rahul, is it all right? Okay. Now I'm gonna give you the next question. That is again from the previous years, and one of the important ideas you will get from the next question. And what is that? Let's talk about it. See, what is the question? And it has been asked in the previous years again. I will keep on checking whether everything is clearly visible to you or not. Suppose Hamiltonian of a conservative system system in classical mechanics. Now, if you are thinking it is classical mechanics question, so it is not a classical mechanics question, it will be quantum mechanics question when you will read the further statement. Is H is equal to omega x p. Okay, next, where omega is a constant. Omega is what? That's a constant. Clear? And x and p are the position and momentum like coordinates. Clear? So they are representing the position and momentum. The corresponding Hamiltonian in quantum mechanics in the coordinate representation, or you can just write in quantum mechanics is. Okay, options are, you can start trying it, like how you will take the steps. Just start doing this and let me know if you are gonna get any option as the correct answer. X delta upon delta x minus half. Option B is minus iota h squared omega x delta upon delta x plus half. Then you are going to have option C as minus iota h squared omega x delta upon delta x. And option D is, that's going to be minus iota h squared omega upon 2 x delta upon delta x. Okay. Please mention your answer, whatever is correct according to you, in the comments, and let me know that this is the correct answer according to you. Okay guys, very good Priya, that's good, that's good. Okay, Rahul, that's good. Very good, Shubham. We will wait for everyone just for some more time and we are going to talk about it. Very good, Ashi. So options A and B we have got from your side. Now let's just see which one is actually the correct one. Very good, Manisha. And what are the steps you have to take to get the final answer for this question? Let's talk about it, guys. And very good, Harin. Okay, now let's talk about it, guys. What are the steps you have to take? See, in this case they have given you a Hamiltonian which is in classical mechanics, and for that they have given you the expression. What is the expression? That is h is equal to omega xp. Clear? And now they are asking you to find the Hamiltonian in the quantum mechanics. Clear? So in this case what we have to do, we know there is a difference which is the common difference between the quantum and the classical part. That is, in classical we don't consider the operators. In classical, if we want, we can write like xp or we can write as px, anything we want. In classical there is no difference, okay, in classical mechanics. But the point is, if I will talk about the quantum mechanics, if I am writing xp as the operators in quantum mechanics, or I am writing px, they may not be, which means not only for this AB or BA. In quantum mechanics they may not be same always, because these are the operators, okay. So in this case we have to be careful about it, like what we are going to consider and what should be the sequence in terms of operators we have to take. So there is a difference in classical and the quantum mechanics, okay, and if you will keep that thing in mind, you will never ever make mistake in any such type of question. Very good, Harleen. See guys, you are having the Hamiltonian given to you, which is omega xp. This is the Hamiltonian given to you, that is omega xp. So it is in classical mechanics. Now when I want to write it in the quantum mechanics, what I have to do, I will consider Hamiltonian as the operator. And since I know if it was omega xp or omega px, in classical there is no difference. Okay, in classical if I am writing omega xp or I am writing omega px, there is no difference. But in quantum it will make a difference. And how I can consider it exactly? It can be either xp or px, because the expression which has been given is in classical, okay. So to get the exact expression, what I have to do, when I will write it in quantum, I can divide it by 2, I can multiply it with 2. So I can write it as what? I can write it as 1 upon 2 omega xp plus px, because in classical mechanics it doesn't make a big difference, okay. I can write it as what? Half omega xp plus px. But when I'm going to write this expression in quantum, what I will do, I have to consider the operator symbols. And when I will consider the operator symbol, I will take xp plus px. And why it is important to take both the sequence? Because we don't know what it is. It can be xp, it can be px. In classical, both are gonna have the same meaning. And the expression which was given was in classical. Done? So that's why it's important to consider both the sequence instead of taking any one. Clear? And that's why to get both the sequence, you have multiplied and divided by 2 and you are getting it. Now what is the operator p value in quantum mechanics you will have? So you need to know about that. That's gonna be operator p is equal to minus iota h cut delta upon delta x. This is the p operator, which means momentum operator. Now when I will write the Hamiltonian operator in quantum mechanics, I am gonna get, I will also need something on which I can operate it, because operator is there, so I need something on which we can operate the operator. So I am gonna take that as sine. Okay, that is the wave function on which we will operate it. So what it will give us? Half omega x cap p is basically minus iota h cut delta upon delta x, okay, plus, and on which you will operate it? On sine. So we will write it right now at the end and then we are just gonna consider the sequence. Sign. Okay, now this sign you can take inside the bracket. Sign will be what? Sign will be the function of x, so you can take it here. So I'm going to remove it from here and I will take it here, which is a function of x. If you want, you can even write it as sine x. You can even write it as sine x here. Done. If you want, you can even show it here sine x, so that it will be clear to you that sine is a function of x. And why it is important to take a wave function? Because we need something on which we can operate the operators. So here we are going to have the next expression. When you will just differentiate this, you will get it as it is. So it's going to be half omega x cap, that is minus iota h cap, h cut x cap, okay, which is this one, and delta sine upon delta x. If you want, you can show that bracket x term, otherwise not required. We are considering it as a function of x. Then minus iota h cut, okay, and then delta upon delta x of x sine x. So first term, second term. Clear? Use the product rule here. So you will get first term as it is, which is x, second term differentiation, which will give you delta sine upon delta x, plus first term like second term as it is now, and first term differentiation will give you 1. Clear? So this is what you are gonna get. You are having like minus sign outside the bracket. What you have to do, you will multiply it within the bracket or open the bracket. So what you will get then, you are going to get from here that expression will be half omega, okay, h cut I can take common, iota I can take common. So what we will get, minus delta sine upon delta x from here, okay, then minus delta sine upon delta x, and also x was here guys, so we need to note it down, x cap, and also here x cap, it's already there, and then minus sine x. Clear? You can see these two terms are same, sorry, not get cancelled out because it's minus and minus, so it will become minus 2, okay, delta sine x, delta sine upon delta x. So you will just add them, minus 2 x cap delta sine upon delta x minus sine x. So what you will get from here, you can take sine x common now, okay, or just write sine or sine x, whatever you want, because it will not make any difference. You just need to know what you are writing. Clear? Take sine common. When you will take sine common, what you will get here, you are writing the expression of what? H sine. Clear? And it's gonna give you iota h cut omega, half I am taking within the bracket, so I will get x delta upon delta x minus half and sine. So what I have got as the h operator, okay, so I am going to get this. We will have to check, is there any option which is showing the same expression? So minus iota h cut omega x delta upon delta x plus half. Why? Because I will take minus sign common. So you will see the options and you are going to find option B is exactly same as the answer we have got. So that's going to be minus iota h cut omega x delta upon delta x plus half. Okay, this is how you will be able to get it. Is it all right and clear to everyone? If there is any step which is not clear, you can mention it and you can let me know about it. If everything clear, that's good. We can take the next question then. So please let me know that is everything all right and clear. We'll take one more question right now. Okay. Done. If there is any doubt at any point, you can mention it in the comments that this point is not clear to you. Is it clear, guys? Okay, that's very good, Priya, and very good, everyone. Next question we are gonna have regarding the different important systems. Okay, so one of the system related question we are gonna take, that is the next one, and that is also a question based on which or similar type of questions we are also having in the previous years, and there are many such type of questions. The energy eigenvalues, the energy eigenvalues of a particle okay, in the potential that is Vx is equal to half m omega square x square minus ax r. You can start solving it. I'm going to write the options, and whatever option will be correct according to you, you can mention it. N plus half h cut omega, related to one of the very important systems from quantum mechanics, we are having this question. A square upon 2m omega square. And even there are different approaches you can take to solve this question. We will talk about all the different ways of solving it. Okay, and with one particular method, we will do the discussion about this one. N plus half h cut omega plus a square upon 2m omega square. The next one is option C. And that is En is equal to n plus half h cut omega minus a square upon m omega square. Option D is En is equal to n plus half h cut omega. Please let me know once you will get it done which one is the right answer according to you. Hello Prince. And guys, at any point if you will have any doubt, you can let me know about it. If any step is not clear, any point is not clear. Oh. Very good, Ruchika. That's correct. Even guys, if somebody else is going to get the answer for this question, you can mention it in the comments that which one is the correct answer according to you. Very good, Prince. That's good. Very good, Priya. Okay guys, let's quickly talk about it. And till now the answers we have got for this question are correct. That is option A. Okay, so everybody has even mentioned option A, but how you will get it, let's talk about that. So till now 3 answers are there. Ruchika, Prince and Priya have just mentioned option A. Okay, and that is correct. See guys, in this case they have given you a potential. So normally we know for the harmonic oscillator the potential expression we take is half m omega square x square, which is equal to this part, but this is the additional term which has been given. So either you can follow the perturbation theory approach, because this is something additional, this is something extra, and that kind of disturbance when we are going to have us in a system, we call it perturbation. So either you can relate it with the perturbation theory, or you can follow the steps I'm going to explain now. By taking these steps, even you will be able to get the answer for your question. And what are these steps? See, Vx is equal to half m omega square x square. Okay, that has been given to you. Take the half m omega square common from here. So what you will get from this term, if you will take the half m omega square common, you will get x square minus 2ax, okay, upon m omega square. This is what you will get. Is it visible? I think yes, but I'm going to show you here right now. Okay? Okay. So this is what you will get if you are going to take half m omega square common. Now what will happen? I can say it is the 2ab form. 2ab form. A square, okay, minus 2a into b. So a is basically this x and b is the remaining term. So what I will do, I will add and subtract the a upon m omega square whole square term here. Okay, I'm gonna add it as well as I will subtract it. So I'm gonna do it somewhere here, and it will be a upon m omega square whole square. So what I have done, I have added and subtracted the same value from the expression, and it will not make any difference. Clear? So a square minus 2ab plus b square form. What is this? This is a minus b whole square. Is it all right? This is what you will get. Was it the minus sign there? I think yes, it is the minus sign. Now what will happen? Very good, Manisha. Very good, Harin. That's good. Now what you will get from here, you will get the form that will match with this expression which I am going to write. See, half m omega square a minus b. B is what? That's going to be a upon m omega square whole square. Okay. And then you will have this minus sign. Okay, I will write here minus half m omega square into a square upon m omega square whole square. So this square will get removed because it will get simplified with this part. So now which form you have got here? That form is matching with half m square capital X square. I can say this is capital X, okay, and this is again same as the harmonic oscillator potential expression, and we know the energy expression or energy eigenvalue for the harmonic oscillator is n plus half h cut omega. So for this term you will have n plus half h cut omega, but for the last term, which was this one, which is a square upon 2m omega square, it is what? There is no x term present, that is just a constant. So you don't need to write any separate energy term for this one. You will just keep it as it is and you are getting your final answer, which will be what? Which will be n plus half h cut omega, okay, and minus a square upon 2m omega square. And you can see it is matching with option A. So that is your right answer. So option A is the correct answer for this question. Clear? So guys, this was the discussion for this session. Now at 1:30 we will have we are just gonna have some time in between. So at 1:30 we will have our another session, which will be our special class, and that's a free live session for all of you. If you have not attended any free live session till now on Unacademy learning app, so to join that session for the first time, it is just a free live session, okay? You will have to put a code there. So you can put you can write Anjali Arora to join that free live session as well. And by applying it, you will simply be able to join it. In the description box of this video, you will have the link for the free live session given to you. And guys, there is a series which is Target JRF, okay, or rank 1 to 100, okay, in the CSIR NET exam. So that is also a free live session series which is going on Unacademy learning app. Okay, I am conducting the sessions in that series on Thursday and Saturday, okay, at 12:30 in the afternoon. So tomorrow again we will have that session, and that's to a free live session. You all can join it. Also guys, as I have provided you the information about a detailed batch course which has recently started, and even you can cover up that part easily with the help of recordings if you have missed one session or two sessions. So you will be able to watch the recordings. You will have the recordings of those previous classes available to you, and you will not miss anything. In the same way, by the other top educators also, many other batch courses are going on, as well as the individual courses by the other top educators are going on Unacademy Plus. So if you think you need the guidance by the top educators, you want to know about the important strategies, you want to know about the important concepts and many important things, under the guidance of top educators, then you can take the Unacademy Plus subscription and you can start your preparation, okay, with all these well structured and well planned courses. The another thing is, whenever you are going to take the subscription, you can use and apply the referral code, which is Anjali Arora, as mentioned here. By using and by applying this referral code, you will get the 10% discount in the total Unacademy Plus subscription amount. Okay, and guys, there are so many benefits which you will get after taking the subscription. So if you think you need the guidance by the top educators, you want to attend the live classes regularly, you want to join these detailed course sessions, then you can take the subscription. Thank you so much everyone for joining this session and for attending it till the end. Thank you.